See, for example, we had to record a measurement of, suppose, 25.55 meters on the field book. But by mistake, we recorded a measurement of, say, 24.27 meters, right? So it must not be, the correct value must not be written by first rubbing it like so. What we must do, we must cross this measurement and write the correct value above it, right? That's the correct form of writing. No overwriting is permitted, right? This field record should be accurate. It should be legible. It should be clear, true, and properly arranged. And this field book should always be kept in safe custody, because it has all the measurements taken during surveying, right? So this was about the principles of surveying, wherein the first principle we studied was that always work from whole to part. The second was that always choose the method of survey that is most suitable for the purpose. The third one was always make provision of the adequate checks. And the fourth or the last one was always record field data carefully. Moving on, let's study about basic measurements in survey. Right? The direction of gravity is taken as the reference line for all measurements in survey. Direction of gravity is taken as a reference line for all measurements in survey. And how do we establish direction of gravity at a point? By suspending a plumb bob freely, right? This direction is taken as the vertical direction, and the horizontal direction is taken perpendicular to the direction of gravity, and the plane perpendicular to the direction of the gravity is the horizontal plane. Horizontal plane is perpendicular to the direction of gravity. Surveying basically consists of what? If you recall the discussions as held in video lecture number 1, surveying consists basically of what measurements? Horizontal distances, vertical distances, horizontal angles, and the vertical angles. Let's take horizontal distances first. Right? A horizontal distance is measured in a horizontal plane. A horizontal distance is measured in a horizontal plane. If a distance is measured along a slope, it's always reduced to its horizontal equivalent. Right? If a distance is measured along the slope, it's always reduced to its horizontal equivalent. This was about horizontal distances. Let's take the next one, vertical distances, also known as elevations. Right? This is the second measurement, basic measurement taken in survey. A vertical distance is measured along the direction of gravity. Right? Vertical distance is measured along the direction of the gravity at that point. The vertical distances are measured to determine the difference in elevations or heights of the various points. Heights or elevations of various points are determined by taking the vertical distances, right? Let's take the third basic measurement in surveying, that is horizontal angle. A horizontal angle is measured between two lines in a plane that is horizontal at that point, right? Horizontal angle is measured between two lines in a plane that is horizontal at that point. How's angle defined? Can you tell me? Angle is basically the difference in direction of two intersecting lines. Difference in direction of two intersecting lines, right? So horizontal angle is measured between two lines in a plane that is horizontal at that point. How about vertical angle? The vertical angle is measured between two lines in a plane that is vertical at that point. And the vertical plane is the plane that contains the vertical line. Vertical plane contains the vertical line, right? So this was about the basic measurements in surveying. Let's move on and study about the instruments used for different measurements. Instruments used for different measurements. Right? What are the four basic measurements taken in surveying? Horizontal distances, vertical distances, horizontal angles, and the vertical angles. Right? And instruments used for measuring horizontal distances are chains, tapes, tachyometers, EDM extra. EDM also, electronic distance measuring instruments, or the electromagnetic distance measuring instruments, right? We measure vertical distances by leveling instruments, or clinometers, right? Horizontal angles are measured by magnetic compass, theodolite, sextants, etc. Magnetic compass, theodolite, sextants, etc. And vertical angles are measured by theodolites, clinometers, sextants, etc. Theodolites, clinometers, and sextants, etc. Right? So this was about the instruments used for different measurements in surveying, wherein we measured the horizontal distances by chains, tapes, tachyometers, and EDM, etc. Vertical distances by leveling instruments, tachyometers, etc. And horizontal angles by clinometers, magnetic compass, theodolite, sextants, etc. And we measure vertical angles by theodolites, clinometers, and sextants, right? This was about the instruments used for different measurements in surveying. Let's move on and study a very important topic, that is methods used in surveying. Basic methods used in surveying. Basic methods used in surveying. See, all methods of surveying involve the measurement of angles and distances in the horizontal and vertical planes, and the location of various points in these planes are determined by applying various trigonometrical and geometrical processes. We apply various trigonometrical and geometrical processes, and the position of the points are fixed in these planes, horizontal plane and the vertical plane. Right? But in surveying, they are known by distinctive terms, and let's study about them. The first is methods for fixing position in the horizontal plane. Methods for fixing position of a point in a horizontal plane, and the basic methods for fixing the position of the points in horizontal plane are intersection, angle and distance method, and resection. Right? So these are the three methods by which we can fix position of a point in a horizontal plane. Let's study intersection first. Let me illustrate this with the help of a diagram. For example, this is a triangle ABC, and we have another framework of triangle. Let me suppose this is point D and this is point E. Right? On any area of land to be surveyed, it's always possible to select 2 points A and B and to measure the distance between them. Right? Thus the position of these points are fixed. Right? And sometimes the position of these 2 points are known either in the form of a rectangular coordinates or in the form of points marked on the map or a plan. And in turn, we have 2 divisions of intersection. First one is intersection by angles, and the second one is intersection by distances. Let's study intersection by angles first. Right? The position of another point C with respect to AB can be known how? It can be determined by measuring the angles CAB and CBA. Right? The position of the 2 points A and B is fixed. We know the distance between them. Then what we'll do? We'll measure the angle CAB and CBA, and the position of the point C will be obtained by plotting these 2 angles. And the triangulation survey, let me write it down for you. Triangulation survey, which provides us a large network of horizontal control points, is based on this method, intersection by angles. Right? The lengths of the sides AC and BC are calculated from the measured length AB and the angles CAB and CBA. So we know now this distance and this distance also. Then from these distances, this will serve as a baseline for this triangle, and this will serve as a baseline for this triangle. And then by computing this angle and this angle, we can fix the position of the point D. Similarly, we can fix the position of point E. So this is known as intersection by angles, and the triangulation survey is based on this method. The next one is intersection by distances. Right? Alternatively, the position of the point C relative to the line AB can be determined by measuring the horizontal distances AC and BC and not the angles, right? So this process can be extended to the adjacent triangles ACD and BCE by measuring the distances CD, DA and CE and EB. Chain surveying is based on this method. This is known as intersection by distances, and chain survey is based on this method, intersection by distances. See, modern trilateration survey in which we use ADM for measuring horizontal distances also based on the method of intersection by distances. So chain surveying and trilateration survey in which we use modern ADM instrument is also based on method of intersection by distances. This was the first method by which we can fix the position of a point in a horizontal plane. The next one is angle and distance method. Right? Angle and distance method. Let me illustrate this with the help of a diagram as well. The position of the point C with respect to the line AB can be determined by measuring the horizontal distance BC and the angle ABC. The position of the point C with respect to the line AB can be determined by measuring the horizontal distance BC and the angle ABC, right? This is the most direct way of determining the position of the point C, and the traverse survey is based on this method. Traverse survey is based on the method of angle and distance, right? The position, after we fix the position of point C, the position of the point D can be determined by measuring the horizontal distance CD and the angle BCD. And this can be then used repetitively to succeeding points which are not shown in the diagram. This was about the angle and distance method, and the traverse survey is based on this method. If you may recall the discussions held in video lecture number 1, wherein I told you that there are two types of theodolite surveys. One is traverse and another is triangulation. Triangulation method is based on intersection by angles, and the traverse survey is based on angle and distance method, right? Moving on, the third method is known as resection, right? Let me illustrate this with the help of a diagram as well. A, B, C, and let's suppose this is point D. Right? We have 3 points A, B, C, and whose positions are known to us. And we have to fix the position of the another point D. How can we do it? We can do so by measuring the angles ADB and BDC. Right? We can measure the angles ADB and BDC, and thus we can fix the position of the point D. And the position of the point D is determined graphically in plane table survey. And by calculations in theodolite survey. Right? So this was about resection. So these were the 3 methods by which we can fix the position of horizontal points in the horizontal plane. The first one was intersection, wherein we had 2 subcategories, intersection by angles and intersection by distances. The second one was angle and distance method, and the third one was resection method. Let's study about method for determining heights, or method for fixing positions in a vertical plane. right? How can we do this method for determining heights, right? The position of a point in a vertical plane is determined by measuring its height with respect to some reference plane, which is known as datum in surveying, reference point or a plane, right? And these three methods are commonly or generally used for determining heights. The first one is ordinary split leveling. Right? In this method, we use a split level to establish a horizontal line of sight. Let me explain this with the help of a diagram. Ordinary split leveling. We'll keep a graduated rod or a staff at this point. For example, let's suppose that the position of this point is known to us. And we have to find the position of, let's suppose, point D. Right? We have kept a graduated staff or hair, another graduated rod or a staff or hair, and we have used a leveling instrument fitted with a telescope, right? And let me write down the points over here. For example, it's point AB, right? What will we do first? We'll establish a horizontal line of sight. Let's suppose the benchmark here was 100 and we took the reading and it came out to 2 on the staff. So this line is established and its elevation is, right? Now we'll keep the staff at the point D, whose elevation we have to check, right? And we'll take the reading. And let's suppose if the reading here comes as 1, so what will be the elevation of this point? AB has 102 because the reading on this staff came out to be 2. So the elevation of this point will be 101. Right? Thus, the level of the point D is 101, and if we'll compare it with the C, the height will be 1 meters. Right? So this was about the ordinary split leveling, wherein we use a split level to establish a horizontal line of sight, and a leveling instrument fitted with a telescope is used. The next method is trigonometrical leveling. The first one was ordinary split leveling. The second one is trigonometric leveling, right? In trigonometric leveling, the difference of heights is determined using the principles of trigonometry. Let me illustrate this with the help of a diagram as well. will we do first? We'll first establish a horizontal line AB with the help of a theodolite, and then the height of the point C above this line is determined by measuring horizontal distance D and the vertical angle theta, and by using the simple trigonometrical principle, the height will come out to d tan theta, right? So this is about the trigonometrical leveling, in which the difference of heights is determined using the principles of trigonometry. The last one is barometric leveling. Right? In this method, we make use of an instrument known as barometer. And more specifically called as altimeter. Right? See, as we all know that the atmospheric pressure decreases as the elevation of the place increases. As the elevation of the place increases, its atmospheric pressure decreases, right? So the difference of elevations of the 2 points can be determined approximately by means of this instrument known as altimeter. And how can we determine this? From the difference of atmospheric pressure at the 2 points. It will determine the atmospheric pressure at the 2 points, and we can have an idea of the difference of elevations of the 2 points, right? But this method is not that accurate, and this is used in reconnaissance survey before the start of the actual survey. We make use of this method in reconnaissance survey before the start of the actual survey. Now, what is a reconnaissance survey? It is a survey which we conduct initially, like it's to have a general idea of the topography of the area, right? It's known as the reconnaissance survey or recce. To have a general idea of the topography, we conduct this survey. It's known as reconnaissance survey or recce. This gives us a general idea of the topography before we start with the actual survey work. Let's move on and study about units of measurements. Right? See, there are basically two types of measurements taken in surveying. One is the linear measurement. And another is angular measurement. Right? Let's study linear measurement first. The unit of linear measurements is meter, right? And in addition to the unit meter, we sometimes use its submultiples and multiples like decimeter, centimeter, or millimeter as well, right? Right? Or we can use its multiples like decameter, hectometer, and kilometer as well. A decameter is equal to 10 meters. Hectometer is equal to 100 meters. And kilometer is equal to 1000 meters, right? So this was about the linear measurement of lengths, wherein the unit is meter, and we may also express in its multiples and submultiples, right? How about area? Area is usually expressed in meter square, and occasionally we can use some other ways of expressing area are hectares or square kilometers, right? Wherein 1 hectare is equal to 10 raised by 4 meter square, and 1 square kilometer is equal to 10 raised by 6 meter square, right? And it must also be noted that 1 hectare is equivalent to 2.47 acres, and 1 acre is equivalent to 4046.86 meter square, right? And 1 acre is equivalent to 0.405 hectares, right? This was about area, and the volume is usually expressed in cubic meters, right? So this was about linear measurements. Now let's study about angular measurements, right? The basic unit of measurement of an angle is radian, right? And it's defined as the angle subtended at the center of a circle by an arc equal in length to its radius, right? And there are 2 pi radians in one complete rotation. How many radians in one complete rotation? 2 pi radians, right? But this unit radian is used mostly in mathematical expressions, and in regular field work we take angular measurements in one of the following systems, and these systems are the sexagesimal system, the centesimal system, and the hour system. Let's study sexagesimal system first, right? This system is used in most of the countries, including ours, that's India, right? And in this measurement, one complete rotation is divided into 360 degrees, right? One complete rotation is divided into 360 degrees, right? And the degrees further subdivided into minutes and seconds. And it must be noted by the students that most serving instruments are graduated according to this system, the sexagesimal system, right? Let me write down it for you. One complete rotation is divided into 360 degrees, which is in turn divided into degrees and seconds, wherein 1 degree is equivalent to 60 minutes. And 1 minute is equivalent to 60 seconds. Right? 60 minutes and 60 seconds. Right? And we must also note that 1 radian is equal to 206,265 seconds. 1 radian is equal to 206,265 seconds. So this was about the sexagesimal system, which is used in most of the countries, including ours. And in this system, one complete rotation is divided into 360 degrees. The next one is Centesimal system. Centesimal system. This system is common in most of the countries of the Western Europe, and in this system one complete rotation is divided into 400 grades. Right? One complete rotation is divided into 400 grades, and the grade is further subdivided into centesimal minutes and centesimal seconds. Let me write it down for you. One complete rotation is divided into 400 grades, which is further subdivided into centesimal minutes and centesimal seconds, and one grade is equal to 100 centesimal minutes, right? And 1 centesimal minute is equal to 100 centesimal seconds. 1 centesimal minute is equal to 100 centesimal seconds, right? So this was about the centesimal system, which is used in most of the countries of the Western Europe, right? The third and the last system is the hour system, which is the form of measurement of angles. Angular system. The third one is hour system, right? The first one was hexadecimal system, the second was centesimal system, and the third one is hour system. This system is used in astronomy and navigation. Right? And according to this system, one complete rotation is divided into 24 hours. Right? And the hour is further subdivided into minutes and seconds, wherein, let me write it down for you. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. Right? So this was about the units of measurement, and we studied about linear measurements and angular measurements, and we studied about the three methods by which we take the angular measurements: the sexagesimal system, the centesimal system, and the hour system. With this we conclude today's lecture, and the chapter Introduction and Basic Concepts will be followed in the next video lecture as well. And stay tuned for that, and for more civil engineering related concepts, join the Aligned Stars community.